In this question, we've been told that the discrete random variable x has a probability generating function as defined by the function below. So I'm just going to write out the distribution, and we've been told to find the value of the constant k. There's an unknown k here. The fact we're going to make use of is that we know the gx of 1 will always equal 1. If we substitute 1 for the dummy variable t, we're going to get answer of 1. That's because if we had this in polynomial form and we substituted t equals 1, we'll just be left with the probabilities, all of the probabilities for the distribution, and we know they add up to 1. Okay, so doing that substitution actually makes this complicated nested bracket expression look a lot simpler. Got 1 over k times 6. 6 over k must equal 1, therefore k equals 6. Next, we're asked to find the probability that x is in between 4 and 6.6. This is going to be hard to do without me being able to see the probability generating function in expanded polynomial form. So I am going to start by multiplying this out. The bracket, the internal bracket, when we square, we get 1 plus 2t plus t squared. I'm going to multiply in the 1/6 t cubed. And that makes this polynomial. From here, we should be able to put this together and form the probability distribution. The powers of t are the x values, the individual outcomes, the sample space, where the coefficients of each of those terms are the associated probabilities. So just stopping here and having a good look across, we notice that yes, these probabilities do add up to 1. This is the exhaustive list of probabilities and outcomes. What probability range were we trying to find? We wanted to find the probability that it's in between 4 and 6.6. Well, since this is a discrete distribution, certain values don't exist. And we know we don't have any decimals. So in between 4 and 6.6 is the same as in between 4 and 6. And 6 doesn't even actually exist in this distribution. So it's really the same as saying in between 4 and 5. It's these two outcomes, these two probabilities that we're looking for. So quite a nice look at a half. The probability x is in between 4 and 6.6 is 1/2. Next, we're told that there are two independent observations of the random variable x1 and x2, and we're asked to write down the probability generating function of the new random variable w, which is the sum of those two. Well, let's just write down the combination here. W equals x1 plus x2. The generating function that represents the sum of two random variables is the product of the two generating functions for that particular random variable. So in this case, the generating function for w is going to be the generating function for x multiplied by the generating function for x, otherwise known as squaring. So this expression that we have, 1 over 6 t cubed multiplied by the original bracket, that needs to be squared. And I hope you can see straight away that we're going to have 1/6 squared, so that's 1 over 36. T cubed squared gets us t to the 6. And I don't really need to process this bracket. I can just write the bracket as squared. And now this is good enough to be the probability generating function of w. Remembering that this is a 1 marker, we wouldn't be expected to now go ahead and expand and multiply to get it into polynomial form. This is fine.